Boom! Alright, so in the last video, we saw that we had the dividend x to the power of 4 plus 2x cubed minus 13x squared minus 14x plus 51. Yeah? And we saw that when we divided f of x, which is all of that, by x squared plus x minus 2, we got a remainder of 27. And we got the same remainder regardless of the root that we use. So remember, we found the root of this, because this is a quadratic, and we had two roots, x equal plus 3 and x equal minus 4, both of which we substituted into the dividend, and on both occasions we got the same remainder of 27. So in this case, I'm going to do another example. In this case, the divisor is a factor of the dividend, just to demonstrate the point that you will actually get a remainder of 0 when the divisor is a factor of the dividend. So again, using the previous question that we would have worked out before, right? We just make the change here, and we make the change here. And we say, just as we did in the last video, we want to find the remainder when f of x equals x to the power of 4 minus 42x squared plus 64x plus 105 is divided by x squared minus 2x minus 3. Alright? Now, of course, the procedure is the same procedure that we have employed thus far. Step 1. Right? Step 1. Yes, step 1 is to find the roots of x squared minus 2x minus 3. That root, when we do that, you say therefore x squared minus 2x minus 3 is equal to 0. So x minus 3 into x plus 1 is equal to 0. Minus 3 plus 1 is minus 2. So therefore, x equal 3, and x equal minus 1. So we have two roots because we divided by a quadratic. If we divided by a linear, we would have one root. If we were dividing by cubic, we would have 3 roots. If we were dividing by a quartic, we would have 4 roots, etc., etc. Now, I just want to make one point here. Usually in the questions, you will hardly get questions where they invite you to divide by a quadratic. And the reason for that is because even if you have 2 roots in the divisor, doesn't matter which root you choose, you'll get the same remainder. So here what? We just structure the question in such a way that we considering the dividend, and usually they will start out by considering one linear root, right? And then after that, you go into other linear roots to complete the question. Yeah? So after I watch these videos now, your next step would be to find questions to do. Right? Questions that I will provide in the session here. Questions, past papers, questions from the textbook, questions on the internet, questions from your teacher, questions from your friends, etc., etc., etc. The questions is what will cement the understanding. So even though I know you enjoy these videos and you understand, because we explain the videos in a nice way, that is not the end. In fact, that is closer to the beginning than it is to the end. Alright? So you really had to make the extra effort now to find questions. Stretch yourself. You will start off with the easy question just to cement things, but then you start to go a little more difficult, and you start to go a little more difficult just to make sure that you really have it done. Right? So we have 2 roots of the divisor. The roots are x equal 3 and x equal minus 1. So just as we did in the previous question, we substitute roots, and again, for the purpose of demonstration, we will use the both roots just to show that we will get the same remainder. Into f of x. That is step 2, right? So this is step 1. This here is step 2. All right, so let me substitute now. This time we go in, let me see, red and green. Last time we went with, what the colors used last time? We use, anyway, that's really important right now. So, let me start with x equal 3. So, f of 3, we used blue and red last time. F equal 3 is equal to 3 to the power 4 minus 42 by 3 to the power 3 squared plus 64 by 3 plus 105. 3 to the power of 4 is 81 minus 42 by 9. 64 by 3 is 192 and plus 105. Alright? 40 is 12, 60 is 18 and 119. Just making sure. Yeah? 81, 42 by 9, 420 minus 42 is 20, 22, 378. Alright? 378. 9 2s are 18, 9 4s are 36, and 137. Right. Plus 192 plus 105 is 297. Don't try to do this in an exam unless you really could do it. Right? If you need to use the calculator in the exam, use the people calculator now. No shame in the game. The exam is not the place to show off. Alright? Nice. So 81 plus 297 is 71 is 8, 29 and 8 is 37. So you'll have 378 minus 378, which is our good friend 0. So when we substituted x equal 3 back into the dividend, we got a remainder of 0. So we know that x squared minus 2x minus 3 is a factor of f of x. And if we want to demonstrate, just for the sake of argument, we could substitute x equal minus 1 into the dividend as well. So that's what we're going to do now. Alright, so we make some space. Yeah? So we say, how we started? We start here now. So we say f of minus 1 is equal to minus 1 to the power of 4 minus 42 by minus 1 squared plus 64 by minus 1 plus 105. Minus 1 to the power of 4 is still 1. Minus 42 by 1 minus 1 squared is 1. Note how careful I am being with the issue of brackets. You have to try your very best not to make too much mistakes in here. And again, just as I would have explained earlier on, this is one of the differences between add maths and maths. You see how long these things are? A lot of minus signs in between. There are so many areas, so many opportunities where you can make a mistake. So you have to be doubly careful. All the normal precautions that you'll take with maths multiplied by 2 or 3 for add maths. Plus 64 by minus 1 is minus 64 plus 105. So 1 minus 42 minus 64 plus 105. So we take all the negatives together and we take all the pluses together. So 1 plus 105 is 106. Minus 42 minus 64 is also 106 with a minus sign in front of it. And that will give you 0 as the answer. So you got the same 0 when you substituted minus 1 and when you substituted 3 into the dividend. So we show now that x squared minus 2x minus 3 is in fact a factor of f of x equal x to the power of 4 minus 42x squared plus 64x plus 105. So this is basically it where the remainder and the factor theorem is concerned. Right? So this is level 1, ground zero as we could say. All right? The simple ability to find the remainder when some function is divided by another function, make sure and lock that down. Because everything else that you would do where you're using the remainder theorem and the factor theorem would hinge upon that ability to determine the remainder when one function is divided by another function. Do not take it for granted, all right, because it will only get more complicated from here. But if you lock down the fundamentals and you lock it down solid, you will find that you will be able to navigate your way through the complicated stuff and get to the point where you could actually do it and do it with a proper degree of proficiency. All right, so I'm going to end this video now by giving you all an assignment, and again be using questions from the previous video. Same two questions. Okay, so I'm going to clear the board now. The assignment is to 1. In this case we did okay, so your first assignment is to find the remainder when and I'm going to adopt some of the mathematical notation now. When f of x is equal to x4 plus 2x cubed. Come. In fact, no. We can leave out the mathematical notation in the interest of space. When x to the power of 4 plus 2x cubed minus 13x squared minus 14x plus 24 is divided by x squared plus x minus 2, and the second assignment is to find the remainder when x4 minus 42x squared plus 64x plus 16. Let me see. Right, so this time we go on top and this time we go in. Plus 16 is divided by this time we go in x squared plus 2x minus 35. All right? Now, I've given you the answers too. In this case, the remainder is minus 89. That's the remainder here. And in this case, the remainder is 0. So you have the answers. You have 2 questions there to do, following the same template that we would have employed in the 2 videos prior to this one. And this is your remainder and your factor theorem. All right? So we're going to continue with our videos on other aspects of the CSEC AdMaths syllabus. Look out for it. stay in the game and let us get the job done.